These two equations look incredibly similar. They use the exact same bases and the exact same exponents, but changing just one operator from multiplication to addition completely changes the path to the solution. And what happens if we add just one more term to the mix? Let's unpack the hidden mechanics of exponents. Let's start with the first equation on the left. Remember our exponent rule. When multiplying powers with the same base, we add the exponents. So on the left, this simplifies to 3 to the power of 3n plus 3. On the right side of the equation, we have 27 to the power of 26. We can rewrite 27 as 3 to the third power, or 3 cubed. To simplify this, we use the power to a power rule, where we multiply the exponents together. So now we are left with 3 to the power of 3n plus 3 equals 3 to the power of 78. We could have used this rule for the left side too, since we have the same term 3 to the power of n plus 1. Multiplying 3 times, this gives us 3 to the power of n plus 1, all cubed, and using the power to power rule, we would get the exact same result. Since the two sides are equal and the bases are the same, the exponents need to be equal too. This gives us 3n plus 3 equals 78. Subtract 3 from both sides and then divide both sides by 3 and we get our first answer. N equals 25. Now let's solve the second equation. Notice that the terms are added together, not multiplied. We are adding the exact same term 3 times. This is the exact same thing as saying 3 times 3 to the power of n plus 1. Using our exponent rule for multiplication once again. We get 3 to the power of n plus 2 equals 3 to the power of 78. Because the bases match, we set the exponents equal. N plus 2 equals 78. And we get our second answer. N equals 76. Now what happens if we add a fourth term to our expressions? Let's look at these next two equations. Let's write out the multiplication version first. Just like before, when we multiply powers with the same base, we add the exponents together. Because we have 4 identical terms, we are just adding n plus 1 4 times. So our left side simplifies cleanly to 3 to the power of 4 n plus 4. And this is equal to 3 to the power of 78. Once again, the exponents need to be equal to each other. So 4n plus 4 equals 78. Subtract 4 from both sides and then divide both sides by 4. We get n equals 74 over 4 or 37 over 2, which is equal to 18.5. Now for the very last equation, this is the trickiest one. We are adding the same term exactly 4 times. This can be rewritten as 4 times 3 to the power of n plus 1 equals 3 to the power of 78. We need to take a different approach here because there is nothing we can do with that 4 on the left side. So we divide each side by 4 and now we have 3 to the power of n plus 1 equals our power of 3 over 4. The result here isn't going to be as pretty as before. To pull the n out of the exponent, we need to take the logarithm base 3 of both sides. On the left side, this gives us just n plus 1. On the right side, we use our log division rule. So n plus 1 is equal to 78 minus log base 3 of 4. To isolate n, we subtract 1 from both sides, which leaves us with n equals 77 minus log base 3 of 4. That is our solution to the second equation. If you plug it into a calculator, it comes out to approximately 75.74. And there you have it. By adding just one more term to the mix, we went from simple integers to a logarithmic decimal answer. Math is all about the details. If you liked this video, you can find more treasures in the attic by subscribing. Until next time, take care of the logic and the beauty will follow. Enjoy the rest of your day.